This version of swap function is used to demonstrate the use of passing by address in writing the functions. Especially in this function, we have two arguments. They are x and y, which are integer pointers. That is, while calling this function, we are supposed to send addresses of two integer variables. In the function, we have used a temporary variable or scratch variable known as t. That is an integer type. Initially, whatever value available in the memory pointed by this pointer variable x will be assigned to t. In the next step, whatever value available in the memory pointed by the pointer variable y is copied into the address or memory which is pointed by the pointer variable x. And then the value of t that is stored in the memory which is pointed by the pointer variable y. In the main program, we have declared two integer variables m and n. Their values have been read with the help of the scanf statement. Verify the table that in the memory of the variable m, we assume that 12 is stored. That is, the user is entered 12, and also in the memory of the variable n, the value n 7 is stored. That is, user is assumed to be entered second number as 7. Also, remember the addresses of these two variables m and n as 10018, 10020. Here, you have to understand that we are assuming that on this mission, whatever we assume that the program is executing, the integer takes 2 bytes. Thus, the memory address which is allocated for a variable m is 10018. Thus, the memory which is allocated for n becomes 10020. Now, we are calling the function swap. If you see the prototype of the function swap, we may find that the swap function requires two integer type of addresses. Thus, from the main, we are sending addresses of these variables m and n. That is, ampersand m, ampersand n, we are sending as an argument for this function swap. That is, we are sending 10018 and 10020 to the function. Obviously, these values will be assigned to the pointer variables in the function, that is, the variables x and y in the function. After we return from the function, the printf statement tries to print the values of these variables m and n. Whether these are going to get changed or not, we will be knowing in the coming slides. We are trying to simulate how this function will be really executed on the machine. Already we understood in the previous examples also that whenever we call a function, memory will be allocated for the formal arguments and also scratch variables. In this example, function swap, we are having two variables x and y and also a scratch variable t. Thus, the memory for x will be allocated. And also remember that from the main function, we are sending ampersand m as first argument. Thus, the m address, that is 10018, is sent into this function. Thus x value, starting value of x becomes 10018. Again, memory for the variable y will be allocated. From the main program, we are sending the second argument as ampersand n, that is address of the variable n, that is 10020. Thus y value becomes 10020. However, we have to remember, or we have to see the one important aspect here. The address of the variable x is 10026 and the address of the variable y is 10030. You can see the table, the difference of 4. So actually we know that today most of the operating systems are 32-bit operating systems. On these missions, pointer variables takes 4 bytes. X and y are pointer variables. Thus, if x address would have been 10026, next 4 bytes including 10026 are related to x. Thus y value, y address is 10030. Now memory for the temporary variable t will be also assigned. Here also you can verify the address of the variable t, that is 10034, because y is a pointer variable, it requires 4 bytes. Thus the starting address of y is 10030. Thus it will be taking 10030 to 33 as the memory of this variable y. Thus the next following byte, that is 10034 and 35, will be the memory which is allocated to the variable t. Now t is equal to star x, the statement is executed. What is the current value of x? 10018. That is, it is the address of the variable m. Star x means the value in that memory, that is nothing but 12. Thus t value becomes 12. Now just we want to have a small deviation. Already we understood that the address of x is 10026, y is 10030, t is 10034. Now let me ask you, what will be the address of next variable if probably we have declared after t? Now star x is equal to star y statement will be executed in the function. Y value is 10020, that is it points to the address of the variable n. Thus star y, that is nothing but the value of n, that is 7. That will be assigned to star x, that is it will be stored in the address which is pointed by the pointer variable x, that is nothing but m variable. Thus now m value will become 7. Now star y is equal to t statement will be executed. What is the value of t now? 12. What is star y? Y value is 10020, which is some memory cell, that is nothing but the address of the variable n. Star y, the value in that memory, that is just same as n. So star y is equal to t means now 12 will be stored in the memory of the variable n. Now memory which is used for the variable t will be deallocated. Now memory which was allocated for the pointer variable y in the function, that will be deallocated. Again the memory which was allocated for the pointer variable x in the function, that will be also deallocated. Now the program control is back to the main. You can verify the values of the variables m and n. Now their values are 7 and 12. Before the function call, their values are 12 and 7. After the function call, their values are now got exchanged. Thus we can understand that if we wanted some modifications to be done on a scalar variables in a function, and those modifications should be visible in the Kali program or Kali function, passing by address is the preferred approach.